Hi and welcome back. Today we are going to take a look at this vintage gyro. This gyro is an horizontal gyro or azimuth gyro if you prefer. It permits the measurement of the heading. This one is roll stabilized. Inside we have an horizontal gyro. It is probably identical to this one. I have described this one several months ago. You can click somewhere here if you want to watch this video. You can see here it is written rotor-S gyro. A rotor-S is something which permits to reduce the residual torque of the ball bearing. So inside we should find exactly the same model. The roll stabilization permits to keep this complete assembly horizontal. So therefore we should find inside this box here a servo motor which permits to rotate completely the gyro inside. So therefore even if the aircraft performs a complete rotation, the gyro inside will be horizontal. There is here a list of modifications. Here there is a large connector with large pins as well. We can see here the gyro itself. It is effectively the CL11 gyro. So it is exactly this model here. And you can see that the complete gyro is linked to this gear for the motor. And we can hear a switch, which seems to be this one here. Okay, we should have one motor and we should find a control transformer somewhere. We can see here two commutators. They are accessible through this plastic cap here. And here there is another thing. I don't know exactly what is this part. Here we have two micro switches. There is a kind of electromagnetic clutch here. And there is a detection of the position here. The solenoid permits to lock the position here. You can see the locking mechanism. So this one permits to disengage the roll servo motor, and this one permits to lock the roll of the gyro. In that case, we have something equivalent to a classic horizontal gyro. And here we have an electronic module, which is probably the servo amplifier. It is written on the other side, servo amplifier type C. So we can see we have several parts here, 3 transistors, several passive parts. We can see here other passive parts and a few diodes. It seems that we have 2 diodes. Reference is KS42. I will start by the reverse engineering of the servo control of the roll of this gyro, and after that I will try to make it work. So this is the servo motor, and we can see that there is something else here. This thing seems to be a potentiometer. Now we can see here other parts. There is here a bridge of diodes, several resistors. This is the socket for the servo amplifier. We have 2 cylindrical things here, probably transformers or coils. We can see here several capacitors. There is one relay. There is a small transformer. This potentiometer is actually the feedback potentiometer. It is not something common. Generally, there is a synchro. We can see here the servo amplifier, serial number 977, made in England by Sperry Gyroscope. The thing is sealed. Even if it is not absolutely necessary, it is better to do the reverse engineering of this amplifier. I will see if I can open it easily. This is the servo amplifier. We can see here two transistors, and we have here two transformers. There is another one, the big one here for the power supply probably. We can see the symmetry here, so the emitters are connected together through resistors of 33 ohms, 22 actually. And you can see that there is a capacitor here between these two collectors. And we can see two other transistors. There is here a diode. It's maybe a Zener diode, I don't know. The schematic of this servo amplifier is here in the middle. There are two stages. The motor is here. The reference winding is connected to 115 volts power supply through these capacitors. The input of this amplifier corresponds to the primary of this transformer. Here we have the feedback potentiometer, and the input of that system should be another potentiometer. The mechanical properties of this potentiometer should be absolutely identical to this one. So probably on the vertical gyro, we should have the same potentiometer with the same gear train. This difference is amplified in order to have a null voltage here, but we can see also that we have the generator in series. So this permits to have a damping of the control loop because of the high gain of the servo amplifier. This voltage here is very low. Across this winding, there is an AC voltage which is proportional to the velocity of the shaft of the motor here. We can see that this voltage corresponds to the difference of these two voltages, which is the error voltage. That means that when the error voltage is null, the velocity of the shaft is null also, so this permits to have the stability of that system. For the test of the control of the whole of this gyro, I have connected this potentiometer to the input here. It is connected between ground and this AC voltage, which is the same than the feedback potentiometer, of course. This is why this reference voltage is connected to one pin of the connector. This potentiometer is normally present inside the vertical gyro. Let's turn on the power supply. This thing works perfectly.